this presentation is about the wheel-rail contact model and validation. And also, during the validation exercise, we found something interesting, that is the creep force build up keep increasing, even though load and the creepage are constant. So that need to be further investigated.
Thank you, Jingao. Sundar?
Yeah, I think I have something to say. It's always challenging to estimate anything in real time. So, but we are still working on that. So time is money. So hopefully we will be able to detect things in real time, what we are doing. So yeah, that's all to add.
Thank you. And Jinjiao?
In this presentation, we present a contact force identification model by combining some conjugate theory and Kalman filter and contact theory. And we use some simulated result and test field result to verify the model partly. And furthermore, in the model, we can obtain the contact force and the contact some parameters in the same time. Thank you.
Thank you. And Maria Cristina?
We think that this method, this evaluation method of wear could be useful because we have a 3D evaluation instead of 2D profiles as usual. And also, we think we can, in the future, as a project, we can put the instruments like that, not this one, but this technology on a trolley or maybe on a bogie to detect, for example, corrugation, or also to detect where for example, the polygonation, the polygonation where. And also, we can use this kind of instruments, this methodology to evaluate the wear in the test rigs. So we have more information. We think it's a new challenge, maybe.
Thank you. Time for questions and comments to all 4 speakers. Yes, Maxime.
My first question to our first speaker is about measurements of contact dimension. We know that it's a lot of techniques exist to measure contact dimensions, and they show different results. In your case, you use only one contact dimension measuring technique. So how, for example, if you take another approach to measure contact spot dimensions, how it will correspond with your simulation results in new cars?
So far, we use the contact imprint. We think this is the most direct way to do the test, and then we measure it afterwards. We can measure it accurately afterwards. The other method, like image test, or even some showing the ultrasound, we didn't try that. We think that direct physical contact give us check the surface, give us the best result.
Thank you.
Yes, we have a question over here.
Yes, I'm from Central Queensland Uni, Australia. I have some questions for third presenter. Okay, yeah. Your predictions using word modelings for the vertical and lateral force identifications. So the vertical identification is always better than lateral. So your conclusion is very similarly a lot of the literature already. So can you give the main reasons why this caused that for the verticals better than lateral. And then the second question is how to improve the correlation factors for both vertical and lateral.
Thank you. Good question. And we introduce the weak model in this contact force identification model because we want to obtain or to solve the contact force of every wheel. And in general, we only obtain the total force of the wheel sets. And here we want to obtain the wheel, each wheel contact force. And to solve, if we direct solve the inverse model, and this model is ill-posed because there are 4 variables, but we only have 3 equations. So we introduce the weak model and plus the contact theory, and we transform the two variables into one variables. That means we use the lateral displacement to express the left and right lateral contact force. So we introduce the weak model.
Yeah.
For the verification, for the especially for the test field, verification, we think that there are much work to do, and you can see this the correlation coefficients between the measured test and the predicted test is no. I think that the factor is some parameters used in the model maybe for practical data, and these parameters of the vehicle is changing. Maybe we need to modify these parameters by comparing the measured results and the prediction results.
Okay.
Thank you.
Okay.
Maybe further quickly.
Well, perhaps we can, or do you have a question for Sundar or Maria Cristina?
You only consider the tangent track.
Perhaps you
How
can
about
continue
the
the
curve?
discussion during lunch. So, do you have any questions for Sundar or Maria Cristina?
We can
Maria Cristina, in terms of future application of your technology, can be installed on rail vehicle, not manually to detect? Can be this technology used to scan rail from rail vehicle, from like an onboard system?
Yes, we are going to scan the wheel. You mean? Do you mean? No.
I mean you install your device on rail vehicle, and after that rail vehicle moves, stop, you scan it.
Yes. The scanning operation is continuous. It could be continuous, but to put the instruments on a trolley or in a bogie, we have to think about because we think there are many problems to apply these instruments because, for example, when you use the instruments, you have to do this movement. So you have to think about the automatic motion, maybe before to put on the trolley. So it's another project. In future, we want to put.
But for example, in order to avoid these movements, can we use more sensors around the rail, or it's still necessary to have movements?
You have necessary to move the.
Yeah, but yes, if you increase a number of sensors to cover whole area.
It could be a solution, but we have just performed this measure with this instrument, and it is a commercial.
My question was about future developments.
Okay, so.
Thank you.
Question from Michele.
Yeah, my question follows from the previous one about future development. Do you also plan to measure, for example, wheel surfaces or other components, and with the same equipment?
Yeah.
Okay, and then I also wanted to ask, did you have information on when that track you had measured was changed or reprofiled the last time?
That track, so the track was reprofiled 3 months before. The length of the track was 10 meters, and on this track, the train passes. The trains pass every 3 minutes every 3 minutes, and we have. Per day, we have 300 trains per day, so we can consider we have to set up a model, a wear model, and to compare with this measure with the model.
Okay, thank you.
Thank you.
Okay, a question for Sundar, perhaps? No?
Sundar, to carry on from my questioning before, you said you had considered real-time adhesion monitoring.
That's right.
How is that done?
How is that done, or how we are
as
doing?
in on the track? How is that? How would you measure real-time adhesion?
Okay, good question. Actually, at this stage, we have not implemented in the real track. So for experimental purpose, we have a scale test rig, and we are working on that. And our sensors are able to get information within a millisecond. So I think that should be enough to get information within our defined real time. So I think 1,000 hertz, 1,000 samples per second. So that's the answer.
And just to follow on from that then, so if you do encounter low adhesion, then how would you recover it? So you have a low adhesion event, how would you recover it?
So you mean if it is low adhesion condition, how do we recover it?
Yeah.
I think we haven't thought of it. So I think this is says we haven't done through it. So I think we have to do some more case analysis as well on that, because at this stage we are on theoretical development plus some initial experiment. So I think that should be the one point which we will consider in our next stage.
Thank you.
Yeah.
Okay, I have a question for Qingao. You have done measurements in your rolling contact fatigue simulator, and you compare it with new cars. You mentioned also in your paper that there have been numerous benchmark tests or studies before. Do you think it's time for a new benchmark study, comparing different software and using your test results?
I would have recommended that. Sure.
Okay. Can you initiate that, or?
If I have the privilege, if the company agreed, why not?
And a quick question to Jinjiao. You're using accelerations to identify your wheel ride contact force. Did you consider using any other type of input, like strains or something like that?
Yes, we only consider the acceleration as the input. We also think we can, furthermore, we can consider the track geometry irregularity as the input. Thank you.
Thank you very much. Can you please join me in showing appreciation for all 4 presenters?